area of the circle is this only. So first we have to find out this curve total area minus this area of the circle, which is this angle is having pi by 6, theta equal to pi by 6. This angle is pi by 6, 30 degree angle. Okay, so at 30 degree angle, we have to find out what is the area of the circle. This area of the part of the circle, okay, we have to subtract, because twice we have to find out area of this, twice of area of this, pi by 18 to pi by 6, we have to first calculate. Okay, so first we have to find out what is the area between these outside the circle and inside the loop. This area we have to find out. Let me now calculate that. What is that area? Okay, so area which we have to calculate here is area required. Okay, first we have to find out this area. 3 times we will multiply that, because then we will take the whole area. This, it says find the area of a loop only. Area of a loop of the curve r equal to a sin 3 theta outside the circle r equal to 1.2a, and hence find the whole area of the curve, then whole area. So first we have to find out this one loop, area of loop, and then the whole area we will multiply that by 3. For this area which is outside the circle and inside the loop, there are 3 loops here because this sin 3 theta. Okay, odd number. That is the point. This is by and by dash and by. No, this is origin here. So what is the area? Now let me find out what is the area here. So if I find the area of the loop, that area of the loop is from angle this theta equal to pi by 18 to theta equal to pi by 6. Okay, and the area of this circle is theta equal to pi by 6, r equal to, so this theta equal to okay, that is for this, and area of the circle we will find out later. For the area, radius is 1.2 a square, and we know that pi a square, this is into theta upon 360. Okay, or we can say that area of a circle is of this, which is having theta only pi by 6, theta equal to pi by 6 here. We will, what is the area of this sector, or we can take that this pi by 3 total area is this pi by 3 angle, so pi by 3 into pi a square upon 360. Area of a sector of the circle we can find out. Okay, that can be subtracted from this whole area. So that we will. Okay, so let me find the required area. The required area of one loop outside the circle is equal to, let me first write what is the area, what is area required here. This is nothing but area twice area, or we can say this is twice area, twice of the area, this half of the loop within this loop here. Okay, so area of loop, or let me take area OBA, this is OBA minus area of the circle, area OBC minus area OBC, twice is minus area OBC. This is what we have. First we have to find out this area. Total area, we could say that OBC, this is the area of one loop, but twice of this will give us the area of this outside the circle. Outside circle means this white portion we have not to find out. This shaded portion we have to find out as the area. Okay, so first let me find out what is this area of the loop here, total area of the loop, and minus this area of the circle we will do. Okay, that will give us twice of this whole area. So let me take that. This is twice Area of this loop will give us, okay, 1.2, and this is r square into d theta, r square into theta, or d theta, r square is this value that we will substitute. So area, this is 0 to, sorry, limits are theta equal to pi by 18, theta equal to pi by 18 to pi by 6, this is pi by 6 here, into 1.2 also, this is r square d theta. First let me find out area of the this half loop. This is OBAO, area of the half loop, this half loop. Okay, so or within limit theta equal to pi by 6, pi by 18 to pi by 6. That can be done, or we can take pi by 18 to pi by 3, not a matter. That is the whole area. Then we can subtract this area of the circle. That can also be done. But let me take twice of this. This 2 to cancel out. R square into d theta only. Let me write here. Area of the loop O, this total area O B A B dash O B A B dash O equal to twice we are calculating. The 2 is cancelled out. That is twice we have done 2 cancelled out. This is pi by 18, pi by 18 to pi by 6 into r square. R square is a square into sine 3 theta. Sine square 3 theta. Sine square 3 theta into d theta. This is the area of this whole loop now, because twice we have done. So that means this area is also covered. And then we subtract this area of the circle within, or we can take that separately, no problem. Area OBC, instead of that we can take area OB, B dash O. That is pi by 3 here, angle, total area, total angle is pi by 3. Within 0 to pi by 3, we can find out the area of the circle. Okay, so angle is given to us, then area we can calculate. What is the area of the circle? So we know that area is pi a square of the circle, but here angle is pi by 18. That is the total area of the circle. So pi by 3, if I say pi by 3, the angle is 2 pi. So if I multiply this by, or divide by 2 pi and pi by 3, so this is area of the sector that we will calculate. And this is pi 18 to this. Let me first find out this area. This is a square, I'm taking outside, sine 3 theta, pi upon 18. This is pi by 6 here, sine square 3 theta. We can do this as 1 minus cos 3 theta, sorry 6 theta, cos 6 theta on 2 into d theta. We can just calculate this like. Okay, so that will give us area of this whole sector. I mean this outside, but this total area of the whole loop, one loop. Area of one loop that we knew that pi a square upon 8 it was coming, but in this case let me check that what this area is coming. This is a square into, okay, this is 1.2 pi upon 18 to pi by 6. It is 1.2 minus cos 6 theta upon 2 into d theta. It is 1.2 here. It will give us a square 1.2 theta minus, this is sine 6 theta upon 6 means 12. Okay, limits pi by 18 to pi by 6. It will give us the area of this. So this area, this is a square into, okay, 1.2 if I take common, it will be pi by 6 minus pi by 18 minus sign, this is pi by pi 0, because sin 6 pi by 6 0, so 6 into pi by 6 means pi, sin pi 0. At cos, at negative value, to be plus sin pi by 3, sin pi by 3, sin 60 degree root 3 by 2. With 3 by 2, it will give us 24. 2 into 24. Okay, so this is area of one loop here. And then we will subtract it, okay, from this, the area of this circle within this area. Okay, so let me take that. This is equal to a square. Okay, it is giving us 18 LCM, 1.2. Let me take 1.2 outside, which is 1.2. I've taken outside. This is pi upon 6 minus pi upon 18. It is 3 pi minus pi means 2 pi by 18. Pi by 9 here. 2 pi by 18 means pi by 9. Plus sign. 1.2 we have taken outside, which is root 3 by 12. So this is the area of this loop here. The total loop from pi by 18 for this whole loop is given. And if I subtract area of the circle, which is this much, what is the area of the circle here? Now therefore, area outside the one loop is equal to area of the loop minus area of the circle inside. Area of the loop minus area of the circle minus area of the circle. Okay, which is OB, B dash, let me take OB, B dash, O. It is nothing but this value. This is a square upon 2, area upon loop, y upon 9 plus root 3 by 12 minus. Now area of the circle is, radius is this. It will be pi a square. This is 1.2 a whole square. What is the area of the sector? Theta upon 360. Theta is here. Total angle is pi by 3. It is pi by 3 upon 2 pi, because 360 pi cancel out, 1 pi. So this is 1.6 only. Okay, so it will give us, let me find out this area. So area of this sector will give us, what is this? Area of the circle within this limit 0 to that I am taking here. It will give us, therefore, area between the loop or outside the circle, loop or outside the circle, outside the circle is equal to, this is a square upon 2 into pi by 9. This is pi upon 9 plus root 3 upon 12. Okay, minus sign. This value is coming out as upon 6. Pi cancel, but upon 6 it will come out, and it will be 4, 6 for the 24. It is pi a square upon 24. Okay, so this is one section outside this. In order to solve it further, it is nothing but pi a square upon 18 plus here, this is root 3 upon 24 a square minus pi a square upon 24. Okay, it is giving us pi a square upon 18 and 24. If I take 73, okay, so a square upon 73, let me take common, 72, sorry, a square upon 72. If I take common outside the brackets, it will give us This is 18 4 is 24, sorry 72. 4 pi a square minus 3 pi, so that means pi a square only. So sorry, pi only. This is pi, because this is 4 pi a square upon 18 upon 72, and this is this. Okay, so that will give us 3 only. 24 3 is 72. Okay, so that means only pi will left over. Pi, this is plus sign, root 3 root 3. This a square upon 72, pi plus 3 root 3. Got the point? This is value outside one loop. If so, these kind of 3 loops will be there, because it is having 3 loops here. This shape here, the same shape here. There are 3 loops. If I multiply this by 3, that will give us, this is area outside one loop. Okay, this is area. This is the area outside the circle. Outside the circle of one loop. Outside the circle in one loop. In one loop. Outside the circle of one loop. So we have to find the total area, entire area. It says find the and hence find the whole area of the curve outside the circle. That means 3 times of this kind we will get. This is 3 upon 72, that means 24 it will be there then. If I multiply this by 3, the total area outside the circle will be the whole area. Therefore, the entire area outside the circle and within the 3 loops is equal to 3 into a square upon 72. It is pi plus 3 root 3. Try to understand. Yeah, this is pi 3 root 3. So this will give us 3 7 24. 24 3 is 72. It's nothing but a square upon 24 pi plus 3 root 3. This is the final answer. So question 10 is completed. Okay, so this is how we have to calculate what is the area of the loop outside the circle. The whole area we have to calculate. Now let me find out what is the question 11 says. The last question. Which is the last question now. Yes, question number 11 now. What does it say? Question number 11 says now that find the area of the loop the curve. Let me take curve y square into, this is a square plus x square is equal to x square into a square minus x square. Okay, so what this curve here? So this is symmetric. Okay, about both the axes, because x-axis and y-axis all are even power. So solution here. Yes, solution. Now this curve is symmetric about. This curve is symmetric about both the axes. About both the axes. Okay, x and y. As x and y both are even power. As x and y both are even power. Okay, this is symmetric about this. Then secondly, what is that another point? Okay, symmetric about both the axes. Okay, and what are the x equal to plus minus? If I put y equal to 0, so x equal to plus minus a. That means this is the curve here. Here if I put y equal to x and okay, this is the tangent line and this is the tangent line here. If I put y equal to x or y equal to minus x, no change in the curve. So this is the curve here. Here a0, y, if I put y0, x equal to plus minus a. So a0, this is minus a0. This is origin. So this is the two loops here in this case. Area of this one loop you have to find out, and then twice of that will give us the, or 4 times of this. If I find out this area, the above area, this is P point, Q point, let me take R here, this is theta and this is d theta, we will find out. Okay, and if this Cartesian coordinates form, then we will take, let me take Cartesian form, doesn't matter, that will be not in polar coordinate, but this is in, let me take one elementary strip here, this is dx here, P and N point, or let me take, this is N point here, or MN, and this is P and Q point, no problem. Elementary strip we have taken, so this is, we will take as this area, and 4 times total area is one of the loops. Find the area of the loop, it means one loop only, we have to find out. This is twice of this area, above area. Okay, so area of this loop in this case, so area of this loop will be 0 to a limits only, and this curve, area of this curve is this. So area of the loop, okay, one loop of the loop means one loop, only one loop we have to find out, is equal to, if I take, this is a point, this is B point here, or P is okay, we have taken P here, P, okay, so this is OAP, twice area, OAP, only one loop, area of one loop, area of the loop of this curve we have to find out. Okay, so this is what we have obtained. Now beyond this, because if I put x more than a, 2, a, 3, etc., the curve will not exist. Even if I put x equal to minus a, more than minus a, or sorry, less than minus a, minus 2a, minus 3a, then also it will be negative, y will be negative in that situation. Or here y square equal to x square into a square minus x square divided by a square plus x square. Okay, so that is the situation here. Now if I put here x more than a, that means 2a, 3a, so then it will be negative. So beyond this point, there is no curve will not exist. Okay, and beyond this point also, if I put x equal to minus 2a also, then whole square will be positive, a square minus 2a square or 4a square will give us negative points. So beyond this also, the y square doesn't exist, or means curve will not exist. Only within these two loops are there. This is what we have to find out the area. Okay, so curve is of this kind. Now area, for area we have to find out y from this. Substitute this area. This is, let me write here, this is twice area of this one loop is limits here 0 to a, 0 to a here, and this is y into dx. Okay, now let me find out this total area. So substituting value of y from this equation, this is a square plus x square. What is the value? This is twice 0 to a, this is x under root a square minus x square divided by under root a square plus x square into dx. What is this? So rationalizing this, we have to multiply numerator and denominator. So rationalizing the denominator multiplying, so multiplying by multiplying the numerator and denominator by multiplying the denominator or numerator and denominator by square root a square minus x square. We have to multiply by this value under root a square minus x square. This will give us twice 0 to a. It is x into a square minus x square only. Why? Because the square root is cancelled out into dx. Divided by this is under root a4 minus x4. So putting x equal to a square sine theta. No problem. Sorry, x square equal to. Putting x square equal to a square sine theta. Try to understand. Therefore, differentiating it with respect to theta, we get twice x dx equal to, this is x dx equal to a square sine cos theta. This is a square cos theta d theta. So x dx equal to a square cos theta upon 2. Now let me solve it here. What are the limits here? So here, therefore x dx equal to, this is a square into cos theta d theta upon 2, 1 thing. Secondly, limits. What we are substituted? We are substituted x square equal to a square into sine theta. This we substituted. So limits here. What are the limits? At now x equal to a, upper limit. This is a square, so sine theta is 1. So at let me take at x equal to a square, sine theta is equal to 1, theta is equal to pi by 2, positive pi by 2. And at theta equal to x equal to 0, theta equal to 0, for sine theta is 0. Sine theta is 0 for 0. Okay, so these are the limits here. Now let me substitute. So this is twice upon 2. So this one cos theta upon 2. Sorry, this a square cos theta d theta upon 2, because x dx equal to, that will come out as upon 2 a square that we take outside. Okay, because this x dx is it's still, let me take, not to take a square, still this is 0 to pi by 2. Let me do it very easily. For x dx is, we have substituted, and this is a square minus a square sine square theta now. Sorry. So x equal to, here it is, x square equal to a square sine theta. A square sine theta only in the numerator. Right? And this is a square cos theta. A square cos theta d theta, 1.2 I have taken outside, divided by, this is a square we will take outside. Now this is 1 minus sine square theta. In the denominator we have, this is a square, it was a4 minus x4, so x square equal to a square sine theta. That means a4 sine square theta. a4 we have taken outside, a square will come out. Alright, this is the point here. Finally, what do we get? So this will give us, let me further solve it. So 2 to cancel out. This is area of one loop here, that loop which we are calculating here. 0 to pi by 2. Here 1 a square cancel out. This a square will come out, so this is a square that we take outside. Here it is cos theta, so cos theta and this cos theta cancel out. Only 1 minus sine theta, this value is left over into d theta. Why? Because this cos theta, which will come out in the denominator, and this cos theta is cancelled out. Here it was a square minus x square, but after the square root is cancelled out only. That was the value. This is the value finally. So let me integrate this. This is a square Integration of 1 is theta minus this is cos theta, and theta is minus cos theta, so this is plus cos theta. Limits 0 to pi by 2. If I put pi by 2, it will give us a square into first pi by 2. It will be 0 at pi by 2, cos pi by 2 is 0. Okay, but when lower limit theta is 0, cos 0 will be 1, it will be minus 1. So a square into pi by 2 minus 2. This is the area of the question, one of the loop. Okay, area of the loop of the curve. 11th question. Find the area of the loop of the curve y square into a square x, a square plus x square equal to x square minus x square into a square minus x square. That by the loop here, this y square into a square plus x square equal to x square into a square minus x square. Area of one of the loop of this. So it says find the area of the loop, means one loop here. This is the final answer. Just this is a question understandable. Usually we have taken this because curve tracing we did initially. After that we are taking step by step everything. These are the area of the closed curves we are doing. Area of closed curves. Okay, so all the 11 questions we have completed now. Okay, so these questions, closed curves or whatever questions were left. Actually, students asked me these questions, so whatever questions left over, and some of them are of closed curves, and some are not of closed, but only one area. For example, this loop, last question was area of one loop only. Okay, so this is area of one loop. Finally, this is done. Okay, so see you then in the next lecture. This is again of the next type we will take. Okay, so see you in the next lecture then. Okay, so this is all over. The whole these 11 questions are completed. Okay, then see you.